Right now, there are 2 trillion galaxies in the observable universe. 2 trillion, and we only found half of them like 5 years ago because our telescopes finally got good enough to see them. But here's the thing, they're not all the same, not even close. Some are getting ripped apart in real time. Some are so invisible we can barely see them even though they outweigh entire star clusters. Some are literally shaped like jellyfish, and some are so rare that we still don't know how they exist.
Number 1, spiral galaxies, the classics. Let's start with the ones you probably picture when someone says galaxy. Spiral galaxies are cosmic pinwheels, a giant disk of stars rotating with a dense bulge of older stars at the center and these beautiful sweeping arms spiraling outward like a cosmic hurricane frozen in time. Here's what blows most people's minds. Those spiral arms aren't actually moving. Think about it. They look like they're rotating, but they're standing waves, density waves. It's like traffic on a highway. The jam isn't moving, but cars flow through it. Stars and gas clouds flow through these arms, get compressed, and boom, new stars start forming. So you've got this constant cycle happening. Stars being born in the arms, living out their lives, dying. New stars forming in the exact same spot because more material keeps flowing through. Our Milky Way, spiral galaxy. Right now, you're living inside one of these pinwheels about 26,000 light years from the center, watching this show play out around you. Number 2, barred spiral galaxies, the focused feeders. Now, here's where it gets interesting. About 2/3 of all spiral galaxies, including ours, have something weird at the center. Instead of a round bulge, they've got a bar, a literal bar of stars stretched across the middle like a cosmic highway. Why? Because gravity built the perfect feeding tube. That bar acts as a gravitational funnel, channeling gas from the outer arms toward the center at insane speeds. All that material gets funneled right into the supermassive black hole sitting at the heart of the galaxy, feeding it an absolutely massive amount of fuel. Think about it. Your galaxy has a bar-shaped structure that's literally designed to feed its central black hole. It's like the universe engineered the perfect cosmic machine for consumption. Here's the thing though, bars aren't permanent. They form, dissolve, reform over billions of years. Our Milky Way might be losing its bar right now, or gaining a new one. We can't tell because the timescales are so massive. We're basically watching a single frame of a movie that takes a billion years to play out. Number 3, elliptical galaxies, the retirees. Spirals are active, dynamic, full of young stars and ongoing star formation. Elliptical galaxies, they're the opposite. These are smooth, featureless, egg-shaped blobs of stars. No spiral arms, no disk, no structure, just a giant swarm of ancient stars held together by gravity. And they're that way because they're dead. Elliptical galaxies contain almost no gas or dust. Without gas or dust, you can't make new stars. So what you've got is billions or trillions of old stars slowly burning out with nothing to replace them. They're cosmic nursing homes. Eventually, they'll dim into darkness. Most elliptical galaxies got that way through catastrophic collisions. When 2 large galaxies slam into each other, the collision is so violent that it destroys the organized disk structure. The arms get ripped apart. Gas gets superheated and blown out into space. What's left is just a shapeless blob of stars orbiting in random directions. The biggest elliptical galaxies are absolute monsters, quadrillions of stars, and they got that big by cannibalizing their neighbors. They just gravitationally ate other galaxies, absorbed them, and kept growing. Number 4, lenticular galaxies, the middle ground. Here's a galaxy type that's basically the universe's compromise. Lenticular galaxies have a disk like a spiral, but they're missing the spiral arms. It's like someone took a spiral galaxy and said, I'm keeping the structure, but I'm deleting the arms. They've got a flat disk and a central bulge, but the disk is mostly just old stars and dead material. There's not enough gas to keep star formation going. It's stagnant, frozen. Astronomers call these S0 on the Hubble sequence, the classification system for galaxies. S0 sits right between spirals and ellipticals. It's like a fossil record of galactic evolution, showing you what happens when a spiral galaxy uses up all of its fuel but hasn't collided with anything yet. Think of them as the middle-aged, settled-down stage.
Active spirals are teenagers partying. Ellipticals are senior citizens in the nursing home. Lenticulars are middle-aged, not going anywhere fast, stuck in that transitional phase forever.
Number 5, irregular galaxies, the gravity glitches. Now we're getting into the weird stuff. Irregular galaxies have no defined shape. None. They're just chaotic blobs of stars and gas with no symmetry, no structure, no order. And you know why? Because gravity had a bad day. Most irregular galaxies are the result of gravitational destruction. A massive galaxy passed too close. A collision happened. The gravitational forces tore the galaxy apart like spaghetti. The organized structure got completely destroyed, and what's left is just a jumbled mess of material slowly trying to reorganize. The Large and Small Magellanic Clouds orbit our Milky Way, and they're both irregular galaxies, and they're irregular specifically because we're in the process of tearing them apart. Their gravity is being warped by us. They're being shredded slowly over millions of years. This is happening right now, not in the distant past. While you're watching this, 2 galaxies that have orbited us for eons are being slowly destroyed. In a few billion years, they'll probably merge with us completely. Irregular galaxies are chaos. They're cosmic car crashes. They prove that not everything in the universe is orderly and beautiful. Sometimes it's just violent and messy. Number 6, dwarf galaxies, the infinite neighbors. Here's a wild fact. The vast majority of galaxies in the entire universe are dwarf galaxies. Not the big, impressive spirals or ellipticals. Dwarf galaxies. Small, faint, containing only a few billion stars. And there are way more of them than the big ones. If there are 2 trillion galaxies and most are dwarfs, that means there are probably over 1 trillion dwarf galaxies out there. And we're just starting to see them now because they're so faint. Dwarf galaxies usually orbit larger galaxies like satellites. Our Milky Way has dozens of them orbiting at the edges. But here's the dark part. Many will eventually be consumed. This is called galactic cannibalism, and it's exactly what it sounds like. A dwarf gets too close to a big galaxy, gravity takes over. The dwarf gets stretched and torn apart. Its stars get pulled into the big galaxy. Within a few billion years, it ceases to exist as an independent entity. The universe is literally eating itself. Big galaxies getting bigger by consuming smaller ones, and it's been happening since the beginning of time. Dwarf galaxies are the universe's unsung heroes. They're the most common thing out there, and most of us never think about them. Number 7, starburst galaxies, the overachievers. Imagine a galaxy making stars at 100 times the normal rate. Not gradually, right now, this instant. Stars are popping off like fireworks. That's a starburst galaxy, and it's usually temporary madness. A starburst gets triggered by something violent, usually a close encounter with another galaxy. Not a collision, just a close pass. The gravitational interaction destabilizes the gas, causing it to compress rapidly. When gas compresses, it forms stars. Lots of them, all at once. In our Milky Way, we make maybe 1 or 2 new stars per year. In a starburst galaxy, dozens, hundreds. The entire galaxy becomes a cosmic nursery, cranking out new stars at an insane rate. But here's the thing, it doesn't last. The burst usually only lasts a few 100 million years. That sounds forever, but it's nothing on cosmic timescales. Eventually, the gas runs out, star formation stops, the galaxy returns to normal. We're seeing starburst galaxies right now. We can point our telescopes and watch them in action. We're literally witnessing cosmic overdrive, watching what happens when a galaxy goes into emergency mode and starts making stars as fast as possible. It's beautiful and terrifying at the same time. Number 8, active galaxies and quasars, the cosmic light bulbs. Okay, now we're talking about the universe's cosmic light bulbs, except instead of a light bulb, imagine a nuclear bomb made of pure energy. Active galaxies have incredibly luminous cores, ridiculously luminous. We're talking about centers that emit more light than all the stars in the rest of the galaxy combined. Hundreds of billions of stars, and the core is brighter than all of them. Why? Because there's a supermassive black hole actively feeding.
When a black hole pulls in matter, that matter gets heated to millions of degrees before crossing the event horizon. It forms an accretion disk, this spinning disk of material spiraling inward, friction heating it up to incredible temperatures. When matter is that hot, it emits massive amounts of radiation. Quasars are the extreme version. Quasi-stellar radio source, that's what it means. They look like stars from a distance, but they're actually incredibly distant galaxies with supermassive black holes absolutely gorging themselves on material. A quasar can shine with the brightness of 1 trillion suns. From billions of light years away, we can still see them. They're so bright that they outshine everything around them. Think about it. Somewhere out there right now, a black hole probably 1 billion times more massive than our sun is actively consuming matter and shining so bright we can see it from across the entire observable universe.
Number 9, ring galaxies, the bullseyes. This one is rare, extremely rare, but when it happens, it's one of the most spectacular things in the universe. A ring galaxy is basically what you get from a cosmic bullseye. A small galaxy passes directly through the center of a larger one, not a glancing blow, a direct hit right through the middle. The gravitational interaction sends a shockwave outward through the disk. That shockwave compresses gas in an expanding circle, triggering intense star formation. What you get is a perfect ring of bright, young blue stars surrounding a relatively empty center. It looks intentional. It looks like the universe sat down and designed a perfect ring shape just to mess with us. The most famous one is Cartwheel Galaxy. It got its name because it looks like a cartwheel. Bright outer ring of young stars, hub in the center, spokes connecting them. That shape happened about 300 million years ago from an impact. The crazy part is the ring is still expanding. Billions of years from now, it'll settle into something more normal, but right now, for a brief period on cosmic timescales, maybe 1 billion years, you get this incredible shape. Ring galaxies prove that even catastrophic collisions can create beauty. They're the universe's art. Number 10, dark matter galaxies, the ghost worlds. Here's where things get properly weird. There are galaxies out there that you can't see. Well, you can see them, but barely. They're mostly dark matter with very few visible stars. Dark matter is the stuff we don't understand. It makes up about 85% of all matter in the universe, but we can't see it. We only know it exists because of gravity. We see how it affects things around it. Dark matter galaxies like Dragonfly 44 are massive. We're talking trillions of stars worth of gravitational mass, but when you look at them, you see almost nothing, just a few stars scattered in an enormous halo of dark matter. Think about it. There's a galaxy out there that's massive enough to be a peer of the Milky Way, but it's almost completely invisible. Most of its mass is in a form of matter we don't understand. We can't see it, we can't touch it, we only know it's there because of what it's doing to the few visible stars within it. This is one of the biggest mysteries in modern astronomy. What is dark matter? Why do some galaxies have so much of it? And are there even more dark matter galaxies we haven't found yet? These ghost worlds might be the most common type of galaxy, and we wouldn't have a clue because we can't see them. Number 11, green pea galaxies, the cosmic glitch. All right, get this. There are galaxies that glow bright green. Not greenish, bright neon green. Like someone took a highlighter and colored a galaxy with it. Green pea galaxies are small, compact, and weirdly rare. And they're green because of what's happening inside them. The color comes from oxygen emission. When oxygen gets ionized, when electrons get knocked off, it emits a very specific color of green light. The brighter and more concentrated oxygen emission, the brighter the green glow. So why would a galaxy be glowing so intensely in oxygen light? Because it's forming stars at an absolutely bonkers rate in an incredibly small space. Tiny galaxies, maybe a few percent the size of the Milky Way, that are forming stars like there's no tomorrow. It's like someone took a starburst galaxy and shrunk it down and concentrated all the star formation into a tiny volume. The result is this compact, glowing green object that looks like a cosmic glitch, like someone made a mistake when drawing the universe. We only discovered green peas in 2009 because they're so small and faint. It took data from millions of galaxies just to identify them. Now we've found hundreds,
and we still don't fully understand what's causing such extreme star formation in such tiny spaces. They're literal cosmic mysteries hiding in plain sight. Number 12, jellyfish galaxies, the tentacled victims. Imagine a galaxy with long trailing tentacles extending for tens of thousands of light years. That's a jellyfish galaxy, and the reason it looks like that is absolutely brutal. Jellyfish galaxies move through massive galaxy clusters at incredible speeds. As they move, they're plowing through the hot gas that fills the cluster. The pressure, ram pressure stripping, rips the galaxy's own gas out of its disk and trails it behind like jellyfish tentacles. All that gas that used to be in the galaxy's disk, gone, stripped away, trailing behind. Without that gas, the galaxy can't form new stars. It's being actively killed by the environment it's moving through. Some jellyfish galaxies have tails stretching 280,000 light years. That's almost 3 times the distance from the Milky Way to Andromeda. Massive, elongated trails of gas and stars being left behind as the galaxy moves. It's actually pretty sad when you think about it. These galaxies are being murdered by their environment. They're being torn apart in real time, losing their ability to make new stars, becoming fossilized versions of their former selves. The worst part? There's nothing they can do about it. They're trapped. The cluster's gravity is too strong for them to escape. They're doomed to be slowly stripped bare as they drift through the cosmic soup. Number 13, HOAG-type objects, the perfect mystery. This one is so rare that it breaks the laws of how we think galaxies form. HOAG-type objects are perfect rings of young stars surrounding a detached yellow nucleus, like perfectly geometrical. It's almost impossible to look at them and believe they formed naturally. Here's the thing. Unlike standard ring galaxies, most HOAG-type objects don't show evidence of a recent collision. There's no obvious reason why they should have this perfect ring structure. They shouldn't exist, and yet they do. The most famous one is HOAG's object, discovered by astronomer Arthur Hoag in 1950. It's this impossibly perfect ring of blue stars with a yellow core sitting in the middle, separated by a gap of empty space. It looks so artificial that when people first saw it, they wondered if it was even real. We have theories about how they might form. Maybe there was a collision so long ago that we can't see the evidence anymore. Maybe there's a mechanism we don't fully understand yet. Maybe they form completely differently from what we think. The fact that we still don't know how these things form is kind of amazing. We have telescopes that can see across the entire observable universe, and yet there are galaxies we look at and go, I have no idea how this is real. Number 14, tadpole galaxies, the violent tail. Picture a galaxy with a bright head and a massive tail stretching over 280,000 light years into space. That's a tadpole galaxy, and that tail is evidence of a violent cosmic event. When two galaxies slam into each other, the gravitational forces are so powerful that they can tear off an entire section of one galaxy, creating this long, elongated tail of stars and gas dragging behind it. Some tadpole galaxies have tails that are absolutely massive, sometimes bigger than the main body itself. They're moving through space with this massive tail streaming behind them, like a cosmic kite. Over time, that tail will eventually dissipate. The stars will disperse, the gas will settle. The tadpole will morph into something else. But right now, for a brief period on cosmic timescales, maybe a billion years, you get this incredible shape that looks nothing like a normal galaxy. Tadpole galaxies are evidence of cosmic violence. They're the scars of collisions playing out across the universe. And they're gorgeous in their own twisted way. Number 15, comet galaxies, the doomed travelers. All right, we're getting into the truly desperate stuff now. Comet galaxies are found only in massive galaxy clusters. They have a brilliant nucleus, the head, followed by a thin, glowing trail of gas and stars, the tail. And here's why they have this shape. They're moving so incredibly fast through the cluster that they're literally leaving a trail of star-forming material behind them. As the galaxy moves through the hot gas of the cluster at speeds of thousands of kilometers per second, ram pressure stripping rips gas out of the galaxy. But unlike jellyfish galaxies with long tentacles, comet galaxies have a narrow, directed tail. The pressure is so intense and directional that it creates this comet-like shape. But here's the dark part. This is a death sentence. The galaxy is losing its ability to form new stars. Eventually, after moving through the cluster long enough, it'll lose all its gas. It'll become a dead, starless husk, a zombie galaxy. The comet galaxy is essentially a galaxy in its final death throes. We're watching its slow extinction play out over millions of years as it drifts through an environment it can't escape. It's beautiful and it's terrifying, and it's happening right now. Number 16, shell galaxies, the archaeological records. Here's something that looks like a normal elliptical galaxy but tells a much darker story. Shell galaxies appear as standard ellipticals, but they're surrounded by faint concentric shells, arcs of stars arranged in perfect geometric patterns. And do you know what those shells are? They're the remains of a galaxy that was torn apart and absorbed billions of years ago. When a large galaxy gravitationally captures a smaller one, the smaller one gets shredded. But the debris doesn't just disappear. It settles into these orbital shells around the central galaxy, creating an archaeological record of galactic cannibalism written in stars. Each shell represents a different time when the debris settled into orbit. It's like looking at the rings of a tree, except instead of wood, it's made of stars. And instead of years, each ring represents millions of years of cosmic history. Some shell galaxies have dozens of shells, suggesting they've cannibalized dozens of smaller galaxies. Each shell is a ghost, a memory of a galaxy that no longer exists. It's basically cosmic evidence of violence. We're looking at the frozen moment right after a merger, with all the scars still visible. Eventually, those shells will dissipate and the evidence will disappear, but for now, we can read the history written in the night sky.
So there you have it, 16 types of galaxies, and they're all out there right now. From simple spirals to chaotic irregulars, from cosmic light bulbs to ghost worlds, from perfect rings to elongated tadpoles, from jellyfish being torn apart to shells recording ancient cannibalism. The universe isn't just diverse, it's wildly diverse. Every galaxy has a story. Every morphology tells you something about what's happened to it, what's happening to it, or what's about to happen to it. And here's the craziest part. We're still discovering new types. We're still finding galaxies that don't fit into our categories. The universe is still surprising us, even with all our telescopes and data. Think about it. You're living inside one of these galaxies right now. You're part of this cosmic diversity. You're not observing from the outside, you're in the middle of it. If you want to see more videos exploring the weirdest, most mind-bending stuff in the cosmos, hit that subscribe button. Drop a like if your brain just got expanded a little bit. And let me know in the comments which galaxy type freaks you out the most. Are you Team Jellyfish, Team Comet, Team Green Pea Mystery? Thanks for watching, and I'll see you in the next universe.